All right, here in this worksheet, we'll talk about logic, specifically Boolean logic and statements in symbolic form. Logic is the study of valid reasoning and argument. We'll categorize statements into either true statement or false statement, and later discuss how well these statements are connected together. You'll notice that last time we talked about sets. Basically, sets will try to categorize elements into different groups. Here, we try to categorize statements into true statement or false statements. So it's going to have a very similar structure as what we studied in sets. So you'll notice that what we study in sets and what we're going to study in logic, they're very closely related. So this is kind of, you can think of this as an extension of what we studied last time. So Boolean logic combines multiple statements. They're either true or false. True or false. So basically in logic, statement is either true or false. So it's pretty much, there's no gray area. It's very black and white. So if statement is true, then a statement is true. If it's not the case, then it's false. There's like nothing in between. So this is like a logical statement. Let's refresh our memory. Let's say I want to say I want to watch a foreign horror movie and need some recommendation. Imagine all the set of all the foreign movies instead of all the horror movies. So A and B, right? Basically, I want the intersection of those two sets, right? So here, so the words A and B corresponds to the set A intersection with B, intersection. So I want the horror movie, I want the foreign movie. It has to be a horror movie and foreign movie. That means the intersection. So when I see the statements A and B, it corresponds to the intersection of set A and intersection of set B. Part B, A or B, corresponds to the set A union with B. So that's a union. And then not A is the complement, right? So A complement, or sometimes I go A with a little dash thing. So it's basically kind of like what we saw in last worksheet. Okay, let's look at number 3. Describe the numbers that meet the condition. Even number and less than 10, and so I'm gonna here highlight and there's like and. So I have to have an even number, it has to be less than 10 and greater than 0. So here, okay, fine. Even numbers greater than 0. So 2, 4, 6, 8. And I was going to say 10, but it says less than 10. So I'm not going to write 10. Notice that I only wrote even numbers. These numbers are even numbers, less than 10 and greater than 0. All right. Let's see. Let's look at, I'm going to have you try B. Let's do C. It says not even. So you can think of odd numbers. So there are possibly 2 possible answers. So it's like, can you just do 1, 3, 5, 7, 9, and goes on forever. It doesn't say like less than 10 or greater than 10, anything. So there are infinitely many numbers there. So not even. Another way of thinking about it is, well, so here, unfortunately, the universal set is not given. So what if like 2.7 is not an even number, right? 1/2 is not an even number. Like square root of 5 is not an even number. So there are all these crazy numbers. So I think for us, I think it makes more sense to say this, just whole number, right? But here, I'm just making out what the universal set is. Okay, I'm going to have you pause and finish number 3. I'll meet back at number 4. All right, now let's look at number 4. The I Get Z Area 6 requirement says proficient equivalent to 2 years of high school. So this is a foreign language or language other than English. It says blah, 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 blah here, or complete of one of the courses below. That's like the foreign language classes we have at PCC. So either you did it in high school or you could do it at here. Basically, that's what it says. So it says who satisfy area 6 requirement. Again, it says something, 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 or something, something. So you could have done it either the first one or the second one or even both. So let's look at Anna. Anna has proficiency equivalent to 2 years in high school, but didn't take any courses below. Doesn't matter. She did high school, so that's yes. Because of this. And John doesn't have proficiency equivalence in to 2 years of high school, but he did it at PCC, so John's yes. So because of that. Stephanie did both high school and she also did PCC as well, which is fine also. So that's yes. So if it's or, you could do the first one, or you could either do the second one, or you could do both. That's also okay. So that's exactly the same logic as union. All right. So now look at a little bit more statements. In logic, propositional statement or just statement is a statement that is either true or false. Again, we're gonna categorize every statement into either true or false. Or this is the statements that we're gonna deal with. It's either gonna be either true or false. Or the statement will claim that it is either true or false. Right? So true or false. So like if I were to equate this to the Venn diagram, either you're inside the circle of the Venn diagram or you're outside of the circle of the Venn diagram, right? Conditional statement is compound statement of the form if and then statement. So sometimes it's called if then statement. I'm gonna say it's conditional statement, but if then statement is more like common way of describing it. So if some statement P, then some other statement Q. So that means if you satisfy the condition, then you're guaranteed the admission to school, whatever, right? If you take out the trash, then you can have your ice cream. So if then statement. So like in real life, we use this if then statement a lot. And that those kind of statements are called, statement is called a conditional statement or if then statement. You can also say if some statement P, then Q will happen, or else, or otherwise S will happen, right? So if you submit the homework on time, then you get the full credit. Otherwise, you get only half the credit, something like that, right? So sometimes I'll add that otherwise or else part. So if then statement can have just if and then, or it can have the third part as well. So let's look at number 7. Suppose that in a certain state, the income tax statement says the following: if blah, 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 and then. So I'm going to highlight if and then. So there's like a if then statement, right? So this is a condition example of a conditional statement. If your annual income is less than 21,000, then the tax rate is 13, and else, otherwise, so okay, I'm going to underline that too. The tax rate is 16. So if you make less money, you're going to have a lower tax rate. If you make more money, then you're going to have a higher tax rate, right? So okay. So like this part of the statement is basically my P. This part of the statement is basically Q, and the last part of the statement is statement S, right? So if P, income is less than 21,000, then we have Q, which is 13%, else you have S, which is 16%. So this is like a structure of the sentence. All right, so Katie's annual income is 34,000. So if part, it says if it is less than 21, so Q is false. So Katie makes more money, so Q, in this case, P statement, Katie makes the P statement false. So that means Q is not going to happen. S is going to happen, right? So that means else is going to happen. So I'm making more complicated than it is. So she's making more than 21. That means she's not going to pay 13. She's going to pay 16. She's going to pay 16%. So okay, 16%. So 16% of what she makes. So 16% of 34,000. So 0.16 times 34000. Again, it's percentage of something. So basically we just multiply that by 34,000. When you calculate that out, I get 5440. So that's going to be her tax. She's going to pay $5,440 in tax. All right, I'm going to have you finish part B of part C of number 7. And I'm going to have you try number 8 as well. Number 8, there's a museum, they're charging $25, but if you are under 7 years old, or, here I'm gonna underline or, over 65, then you get 20% off. So this is a little extra twist. So I have you try number 8 as well, and we'll meet back at number 9. All right, number 9. So these are some useful phrases or words that we use when we make statements. So the first one is universal quantifier. So universal means, again, it's like everything, right? So there are words that describe the entire set, the whole set, entire set, oops. Such as all, every, or sometimes none, right? Because we can think of the described set as a universal set. So that contains like every students who are taking this class, every students who are going to PCC, all students who are going to PCC, right? Or I can say none of the students are going to PCC. So think about people who are not going to PCC. So all the people who are not going to PCC, they'll be like none, right? So none can also work as universal quantifier because none refers to everyone who's not doing something, right? So these are some example. All millennials are tech savvy. Every hipster is a coffee drinker. And here, nobody complete the homework assignment on time because, as I mentioned before, I can rewrite this: everyone did not complete the homework on time, right? So saying nobody completed the homework on time is same as everyone did not complete the homework on time. That's why none can work as a universal qualifier. All right, we also have existential quantifier. I keep calling it qualifier, it's quantifier. Are words that describe the existence of at least one element in the set, such as some or at least one. Notice that in logic, some can also mean one. Like in real life, when you say, I'll bring some drinks, it sounds like you're going to bring more than one drink, right? But in logic statement, if you say there are some drink, it could possibly mean there is one drink. It doesn't mean there's like some drink, at least one, right? So in logic, kind of weird, but some is equal to at least one or more, right? So one could also count as some, just to letting you know. So these are the examples of existential quantifier. And the next one is a negation. It's kind of like a complement, basically. A negation of a statement is the opposite of the quantified statement. So to show the statement, all millennials are tech savvy, to be not true. So let's say somebody made a statement, all millennials are tech savvy. How do I make that not be the case? Or how do I make that statement not true, right? What do I have to do? Do I have to show that every single millennials are not tech savvy? No. In order for it to be not all, I just have to find one person who's not tech savvy. That means it's not everyone, right? Because all means everyone. So all I have to do is find one person who's not tech savvy, then this statement is false. So here I'm going to say, we just need at least one person, right? At least one millennial who's not tech savvy, right? So write down the negation of the statement, all millennials are tech savvy. Well, I just need at least one, so I can say some millennials are not tech savvy. That's all I want. That's all I need, right? Part C, what is the negation of a negation of the statement? So what is like not? Well, that's kind of a trick question. It's the original statement itself, the original. Itself. So if you negate the negation, then you just get the original statement back. Okay. Let's see. Let's look at number 12. Practice some negation. Let's look at. I'll do a few, and then I'll have you finish. I'm gonna try part B and part C maybe. So part B. So no art major student is hardworking. Okay. So in my head, how do I disprove that? Like it's saying no art major student is hardworking. So in order to show that that's not the case, I need one person to be hardworking, right? So in my head, so I'm gonna say some. So at least one is basically some, right? Some art major students are hard working, right? So that's the negation of nobody, means there are some people who had that property. All right, so here, let's look at part C. It says at least one art major student is hardworking, right? What's the negation of that? So they're saying there are some people, or at least one, who's hardworking. So how do I show that's not the case? Well, that means nobody, right? So here, no art major is hardworking. All right. So, okay, I'm gonna have you pause now and then try number 12. So you can write down the negation of each statement. And we'll meet at number 13. Here we're gonna talk about symbolic form of a statement. So we're gonna somehow come up with the symbols to write the statement. So statement A and B, you have to complete, English 1A and 1B. We're gonna write that as A, B, right? The up arrow thing. So that's A and B. In a logic statement, if I see that symbol up arrow, that's A and B. A or B is A or B. Upside down, up arrow, I guess that's down arrow. And not A is the squiggly line A. This squiggly line is called tilde. Tilde. I don't know why it's called tilde, but it's called tilde. And so not A. So sometimes I'm gonna read it like literally not A, but tilde A is not A, right? So notice that A and B, for the set A and B, for the set is A intersection with B. For statement is A up arrow B. Basically kind of same-ish, A or B. For the sets is A union B. For the statements it's like this, right? And then not A, in terms of set is A complement or A dash. In terms of statement is tilde A. So here basically this is with the sets, this is with the statements. So they're kind of similar in some ways. I mean, for a reason, right? Because they're kind of saying the same thing. All right, let's look at the next question. So translate each statement into symbolic form. Let D represent I like dogs, and let C represent I like cats. Personally, I like dogs better than cats. I don't hate cats, but if I had to pick one, they'll be dogs. Okay, so let's look at A. I like dogs or I like cats. I notice it says or, right? So it's gonna be the up down arrow thing. So I like dogs or I like cats. Let's skip to part D. It's not the case that I like dogs or cats. Okay, so it's like, I like dogs and cats. They have this, but they are saying it's not the case. So I feel like that's tilde, which is the complement or the opposite, right? Or negation. So it's like tilde, dogs or cats. Not to be confused with this or C, right? This means I don't like dogs or I like cats. So here I like cats. The original statement is not the case that I like dogs or cats. So this person doesn't like anything, right? So this is different. So that's why I have to put that little parentheses around. Make sure it's not the case that I like dogs or cats. All right, also just a little hint, or I'm just going to point out that if you look at part G, statement G says, I don't like dogs, but I like cats. Versus statement H, I don't like dogs and I like cats. In normal conversation, like, I don't like dogs, but I like cats sounds better. But in logic, I don't like dogs, but I like cats is basically the same thing as saying, I don't like dogs and I like cats. So in logic, these two are basically the same thing, right? So logically speaking, is there a difference between previous two statements? No, they're the same. Right? And number 15 is, I want to see if I can connect the statements with the Venn diagram. So let's see. Let's look at part A. I like dogs or I like cats. So that's the union of dogs and cats. So that's basically section 1, section 2, section 3 there included in there, right? Other example, let's say look at part C. I do not like cats. So that's like complement, right? I don't like cats. So cat is here. My print, it's got print a little weird. 4 is here. 2 is like inside. Different color maybe. 2 is like here. Somehow when I printed it, it printed a little weirdly. Sorry about this. So let's go back to part C. I do not like cats. Cats. This circle is people who like cats. So who's not inside this circle? Section 1 and section 4. So section 1 and section 4. Those are people who do not like cats. So I'm trying to connect the Venn diagram with the statements that you're making. So okay, and so on and so forth. So I'm gonna have you finish the rest of number 14 and number 15. I think that's the end of the worksheet.